Okay, let's have a bit of a blast from the past in the form of a Super 8 movie film of the Skypower Mk4c experimental wind turbine, designed and built by AERO Enterprises, AERO Physics Engineering Research and Operations, which is what I called myself in 1986 when I had to give up nursing due to a bad back, and I was disgruntled with the state of regulations in ultralight aeroplanes, so I retreated into wind turbines. I figured I could use more or less the same skills and knowledge, and carve myself a turbine rotor and suck power out of the sky instead of burning fuel to pump power into the sky. And there weren't any laws against wind turbines. The chief difficulty is getting the alternator going fast enough in the wind that's available, and then switching the alternator on only when there's enough wind to make the electricity. First way to cut down the power loss is to put a 5-watt bulb in the alternator's exciter circuit. And that way, when there's not enough wind, you can only lose half an amp instead of 5 amps. Next trick is to build an omni-directional wind pressure sensor switch and finally adjust it so that it only switches power onto the windmill when there's enough energy in the wind to make electricity. So the switch turns the light on, power goes into the alternator, the exciter circuit produces enough energy to run itself, and the light goes off again. When the wind drops, the exciter circuit is disconnected by the switch, and then it all starts over again when the wind picks up. Now, in the best of the old-fashioned film traditions, pretty soon I'm going to have to change the reels on this, because I've got another short reel of close-ups of the omnidirectional switch in action. Rather than have 3 windmill films, I'm going to have 2. And here's roll 2. Okay, so now let's have roll 2. And as you can see, the switch is made up of a piece of spring steel wire with a copper tube around the bottom of it and 2 sheet steel discs at 90 degrees to each other, which can be slid up the wire in order to make the switch more sensitive and down the wire to make the switch less sensitive. And as the pressure of the wind moves the spring steel left, right, backwards or forwards, the wire that you can see goes up to a piece of copper tube around the spring steel wire, and that copper tube is then touched against a copper ring. So it doesn't matter which direction the wind comes from, it still makes contact. This puts power into the exciter circuit, which is limited in its current drain by a 5-watt bulb. So the most the exciter circuit can draw is half an amp. Without that bulb there, it could draw 5 amps on some alternators, 2.5 amps on others. The looseness that you can see in the main bearings is what eventually brought the demise of this windmill. Eventually, early in 1987, looseness in the bearing blocks allowed the wind turbine to destroy itself. When this blade ran into the pole, at something like 2,500 revs per minute, as a result of gyroscopic precession when I tried to turn the wind turbine off in over 40 miles an hour of wind. The largest fragment of the blade that did not hit the pole speared into the ground less than a metre away from me, and it buried itself about that deep in the ground. So this exploding wind turbine very nearly killed me, which is why I keep it taped together, and it lives in the toilet with all my other broken woodwind fantasies from the days of AERO Enterprises.